Does the term big data scare or confuse you? Fear not. Let us break it down for you. Big data is the act of collecting large data sets from traditional and digital sources to identify trends and patterns. That information is used by companies to improve what they know about customers' wants and needs. The goal should be to make solid decisions based on data and not just hunches. People are increasingly willing to hand over their personal data in return for products and services that make their lives easier. But what does that mean for you, the source of the data? Well, think of it as a trade. Let's say Becky tweets about a store she recently visited. That store could mine data from her tweet and thousands of others to figure out where its customers are and what they're saying about its products. Maybe the store decides to open a new location way across the city because social media shows the demand there is popping. Tweets and Facebook posts are a bit harder to analyze than structured data like store receipts or web traffic. Unstructured text or images require special software to extract their meaning. And since the volume of unstructured data is so large, many businesses need to use special hardware just to organize and understand it. Companies that are on their game use both structured and unstructured data flow to build up their customer insights each step of the way. Pretty crazy, right? Data-driven marketing is what it's all about these days, and every organization should know the 3 V's of analysis if they want to succeed. Volume, the amount of data; velocity, the speed at which the data is generated; and variety, the kind of data available. The more data a business analyzes, the more it can make the experience better for the customer. For a typical company, just a 10% increase in data accessibility will bring in more than $65 million additional net income. So should Becky worry that her information is being passed around between large corporations? Maybe. It's not exactly a regulated practice, but in this day and age is nearly impossible to avoid, and data collection is not going anywhere. By the year 2020, about 1.7 megabytes of new information will be created every second for every human being on the planet. Even the White House has already invested more than $200 million in big data projects. But just because information is collected doesn't mean it will necessarily be used. In fact, only 0.5% of all aggregated data is ever analyzed. But there are steps Becky can take to limit the amount of accessible data. She can read the terms and conditions before installing apps. Some of them ask to access phone contacts, GPS locations, even the mic recorder. Limit geotags on social media, and be aware that anything you type into a search engine will be documented, even in private browsing. So there you have it. Big data is the ultimate business tool of the future, and it wouldn't be possible without you, the consumer.
The quantity of computer data generated on planet Earth is growing exponentially for many reasons. For a start, retailers are building vast databases of recorded customer activity. Organisations working in logistics, financial services, healthcare and many other sectors are also capturing more data. And public social media is creating vast quantities of digital material. As vision recognition improves, it is additionally starting to become possible for computers to extract meaningful information from still images and video. As more smart objects go online, big data is also being generated by an expanding Internet of Things. And finally, several areas of scientific advancement are starting to generate and rely on vast quantities of data that were until recently almost unimaginable. Big data is often characterized using the 3 V's of volume, velocity and variety. Here, volume poses both the greatest challenge and the greatest opportunity, as big data could help many organizations to understand people better and to allocate resources more effectively. However, traditional computing solutions like relational databases are not scalable to handle data of this magnitude. Big data velocity also raises a number of issues, with the rate at which data is flowing into many organizations now exceeding the capacity of their IT systems. In addition, users increasingly demand data that is streamed to them in real time, and delivering this can prove quite a challenge. Finally, the variety of data types to be processed is becoming increasingly diverse. Gone are the days when data centers only had to deal with documents, financial transactions, stock records, and personnel files. Today, photographs, audio, video, 3D models, complex simulations and location data are being piled into many a corporate data silo. Many such big data sources are also unstructured and hence not easy to categorize, let alone process with traditional computing techniques. Due to the challenges of volume, velocity and variety, many organisations at present have little choice but to ignore or rapidly excrete large quantities of potentially valuable information. Indeed, if we think of organisations as creatures that process data, then most are rather primitive forms of life. Their sensors and IT systems are simply not up to the job of scanning and interpreting the vast oceans of data in which they swim. As a consequence, most of the data that surrounds organisations today is ignored. A large proportion of the data that they gather is then not processed, with a significant quantity of useful information passing straight through them as data exhaust. For example, until recently, the majority of the data captured via retailer loyalty cards was not processed in any way. And almost all video data captured by hospitals during surgery is still deleted within weeks. Today, the leading big data technology is Hadoop. This is an open source software library for reliable, scalable distributed computing and provides the first viable platform for big data analytics. Hadoop is already used by most big data pioneers. For example, LinkedIn currently uses it to generate over 100 billion personalized recommendations every week. Hadoop distributes the storage and processing of large datasets across groups or clusters of server computers. Whereas traditional large-scale computing solutions rely on expensive server hardware with a high fault tolerance, Hadoop detects and compensates for hardware failures or other system problems at the application level. This allows a high level of service continuity to be delivered by clusters of individual computers, each of which may be prone to failure. Technically, Hadoop consists of two key components. The first is the Hadoop distributed file system, which permits high bandwidth cluster-based storage. The second is a data processing framework called MapReduce. Based on Google's search technology, MapReduce distributes or maps large datasets across multiple servers. Each server then creates a summary of the data it's been allocated. All of this summary information is then aggregated in the so-termed reduce stage. MapReduce subsequently allows extremely large raw datasets to be rapidly distilled before more traditional data analysis tools are applied. For organisations who cannot afford an internal big data infrastructure, cloud-based big data solutions are already available. Where public big datasets need to be utilised, running everything in the cloud also makes a lot of sense, as data does not have to be downloaded. For example, Amazon Web Services already hosts many public datasets containing government and medical information. Looking further ahead, quantum computing may greatly improve big data processing. Quantum computers store and process data using quantum mechanical states and will in theory excel at the massively parallel processing of unstructured data. As IBM explain, big data provides an opportunity to find insight in new and emerging types of data. Or as Oracle put it, big data holds the promise of giving enterprises deeper insight into their customers, partners and business. In time, big data may also help farmers to accurately forecast bad weather and crop failures. Meanwhile, governments may use big data to predict and plan for civil unrest or pandemics. In a recent report, the McKinsey Global Institute estimated that the US healthcare sector alone could achieve $300 billion in efficiency and quality savings every year by leveraging big data. Across Europe, they also estimate that using big data could save at least $149 billion in government administration costs. In March 2012, the US government announced a $200 million investment in big data projects.